the midpoint formula, the distance formula. So we start from the first topic, which is absolute value. Absolute value describes the distance of a number on the number line. Absolute value of a number cannot be negative, and it is always greater than or equal to 0. Absolute value of C is denoted by C mod. Let us consider the figure below. The absolute value of minus 3 mod is equal to 3. It's like a person walking from 0 towards minus 3. He covered 3 units distance from 0. Since the movement is in the negative direction towards minus 3, this doesn't mean that the distance covered by the person is minus 3, because distance can never be negative. Similarly, you can see the distance covered from 0 to 4 is 4 mod, which is 4. Now we give you the definition of absolute value. For any real number a, we define its absolute value as a mod, which is equal to a if a is greater than or equal to 0, and minus a if a is strictly less than 0. Next, we study some properties of absolute values. Following are the properties of absolute values. Number 1, for any real number a mod is always greater than or equal to 0. Number 2, absolute value of any negative number is positive. That is, minus a mod is equal to a mod. Number 3, for any two real numbers x and y, x minus y mod is equal to y minus x mod. Number 4, for any two real numbers x and y, xy mod is equal to x mod y mod. Number 5, for any two real numbers x and y, x divided by y mod is equal to x mod divided by y mod. Dear students, next we discuss the solving equations and inequalities involving absolute values. We start from example number 1. Solve the equation x plus 2 mod is equal to 7. Okay, first of all, we have to split the absolute value into two parts. That is, we write x plus 2 is equal to 7 and x plus 2 is equal to minus 7. In the next step, we get x is equal to 7 minus 2 and x is equal to minus 7 minus 2. So hence solution is x is equal to 5 and x is equal to minus 9. To check the solution, we substitute these values in the given equation and we get, so in the space of x, we put x is equal to 2. So we get 5 plus 2 mod is equal to 7 and minus 9 plus 2 mod is equal to 7. So that is 7 mod is equal to 7 and minus 7 mod is equal to 7. So both sides are equal. Now we can represent the solution on the number line as you can see. So here 5 is represented on the red dot. Similarly, x is equal to minus 9 is represented by the red dot. Dear students, next we see another example to solve the equations and inequalities involving absolute values. Example number 2. Solve the inequality x minus 3 mod is less than 5. First, we will write the given equation in two possible ways. That is, we will split x minus 3 mod less than 5 in the following way. So we write minus 5 less than x minus 3 less than 5. Now we add 3 to this inequality. So we will get minus 5 plus 3 is less than x minus 3 plus 3 is less than 5 plus 3. We get minus 2 is less than x is less than 8. That is, x is greater than minus 2 and x is less than 8. So our solution set will be equal to x such that minus 2 is less than x is less than 8. So we will get the open interval starting from minus 2 up till 8. So both sides are open. Now we represent this on the real number line. Solution of the given inequality can be represented on the number line in the following way. you can see that x is greater than minus 2 is represented here. So since minus 2 is not included, so we have a blank space, and the arrow shows that all the values above minus 2 are included in the solution set. Similarly, if you look at the other side, the solution is x is less than 8. So here it is represented in the arrow where 8 is not included and all the numbers below 8 are included. Dear students, we see example number 3. Solve the inequality x minus 3 mod is greater than 5. So again, we will split this into parts in the following ways. So we write x minus 3 mod is greater than 5, which is equal to minus 5 is greater than x minus 3 is greater than 5. Again, we add 3 on all sides. So we get minus 5 plus 3 is greater than x minus 3 plus 3 is greater than 5 plus 3. So we get minus 2 is greater than x is greater than 8. That is, we have obtained two parts. In the first part, x is less than minus 2, and in the second part, x is less than 8. So we can write it in the solution set in the following form. Solution set is equal to x such that minus 2 is greater than x is greater than 8. So this is represented by minus infinity to minus 2 open interval union 8 to infinity open interval. So the union of these two open intervals will be our solution set. Dear students, now we represent this solution on the number line. Again, you can see on the number line, since x is less than minus 2, so we have excluded minus 2 and the arrow shows all the numbers less than minus 2 up till minus infinity are included in the solution set. Similarly, on the other side, since x is greater than 8, so excluding 8, all the numbers from 8 to positive infinity are included in the solution set. We solve example number 4. Solve the equation x plus 5 mod is greater than or equal to 7. First, to clear the absolute bars, we must split the equation into two parts. That is, x plus 5 mod is less than or equal to minus 7 and x plus 5 is greater than or equal to 7. So we get x is less than or equal to minus 7 minus 5 and x is greater than or equal to 7 minus 5. So this shows x is less than or equal to minus 12 and x is greater than or equal to 2. So we get the solution set x such that minus 12 is greater than or equal to x and x is greater than or equal to 2. Dear students, now we represent this again on the number line, and you get here that since all the numbers below minus 12 and including minus 12 are here, so we have the dot which is filled. It shows that x is equal to minus 12 is also included in the solution set. Similarly, on the other side, x is greater than or equal to 2, so 2 is also included in the solution set. Dear students, now we see some applications of coordinate system. In economics, we use math widely for analysis and managing. It's very important to learn about coordinate system because in economics, the Lorenz curve is a graphical representation of the cumulative distribution function of the probability distribution of wealth and income. And it was developed by Max Lorenz in 1905 for representing inequality of the wealth distribution, and the calculations are done in rectangular coordinate system. Dear students, you can see the Lorenz curve here. On the x-axis, we have taken cumulative percentage of income, and in the y-axis, we have taken cumulative percentage of households. Line of perfect equality is a straight line shown here, while the Lorenz curve is also shown here. Dear students, now we define rectangular coordinates. It is a system which specifies each point uniquely in the plane by a pair of coordinates. Usually we take xy plane, that is, the horizontal line is called x-axis, which is perpendicular to vertical line, which is called y-axis. Now any point on the plane is represented by xy, where x measures the signed distance to the point along x-axis and similarly y measures the signed distance to the point along y-axis. So this system is also called Cartesian coordinate system. It has 4 quadrants which are represented in the next slide. Rectangular coordinate system. Dear students, on the x-axis we have a representation on the right side for positive x-axis and on the left side for negative x-axis. Similarly, for y-axis, on the up side we have positive y-axis, and similarly on the down side we have negative y-axis. A Cartesian coordinate system is also called as rectangular coordinate system is used to plot points and graph lines. The horizontal line is called the horizontal axis and the vertical line is called vertical axis. These two axes together are called coordinate axes. The plane containing the coordinate axis is called coordinate plane or the Cartesian plane. Location of any point specified by order pair of values x, y. Here x is called abscissa or the x coordinate and y is called ordinate or the y coordinate. Dear students, the Cartesian coordinates, we have 4 quadrants. First quadrant is called quadrant 1. In this quadrant, x and y both are positive. Then we have quadrant 2. In this quadrant, we have x negative and y positive. Then we have quadrant 3. Here both x and y are negative. And lastly, we have quadrant 4. Here x is positive and y is negative. Now we define the midpoint formula. In Cartesian coordinate system, suppose we have 2 points x1, y1 and x2, y2. Then we can find the midpoint of these 2 points using the midpoint formula, which is given by x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Now we define the distance formula. The distance between 2 points x1, y1 and x2, y2 can be calculated using the Pythagoras theorem. That is, the distance between A and B is equal to x2 minus x1 square plus y2 minus y1 square whole square root. The distance formula is derived with the help of this right angle triangle. In this triangle, you can see base is A, height is B and hypotenuse is C, which is represented by A square plus B square square root. Or if we see in the form of coordinate axis, then on the horizontal line we have x2 minus x1 base, y2 minus y1 height. Then the hypotenuse is represented by D and it will be equal to x2 minus x1 whole square plus y2 minus y1 whole square and square root. Now we give an example of midpoint formula. Find the midpoint of the points A is equal to 2, 6 and B is equal to 4, 8. Solution. First we write the midpoint formula, that is x1 plus x2 over 2, y1 plus y2 over 2. Now we substitute the value of x1 and x2, that is 2 and 4. So we get 2 plus 4 over 2. Similarly, we substitute the values of y1 and y2, that are 6 and 8 respectively. So we get 6 plus 8 over 2. So we get 6 over 2, 14 over 2, that is 3, 7. So our midpoint is 3, 7. Dear students, now we give you the example of distance formula for the points A is equal to 1, 4 and B is equal to 4, 0. First we write the distance formula, that is the distance between A and B is equal to x2 minus x1 whole square plus y2 minus y1 whole square and square root. Now we substitute the values of x2 and x1, that is x2 is equal to 4 and x1 is equal to 1. So we get distance between A and B is equal to 4 minus 1 square. Similarly, we substitute the values of y2 and y1. y2 is 0 and y1 is 4. So we get 0 minus 4 square. Now we simplify. So distance between A and B is equal to 3 square plus 4 square square root. So distance between A and B is 9 plus 16 square root, which is 25 square root. So we get the distance between the 2 points A and B is 5.